Well, welcome everybody. I'm Amber Huffman with Google, and this is
Bryan Kelly from Microsoft.
And so we've also been working very closely with Steve Helvey on the OCP S.A.F.E program, and so we wanted to give you an overview. I would like to apologize in advance. I am giving a talk in the storage track, which is ahead of schedule at 11:05, but it's probably starting earlier, so I may step away as Bryan's finishing. So we're excited to talk to you about the Security Appraisal Framework and Enablement Program, but S.A.F.E as a much easier acronym. So we're going to talk through the emerging regulatory requirements we're all seeing, the current assessment model and those challenges associated with it, what's an overview of S.A.F.E, and also talk a little bit about some of the early pilot wins. So one of the challenges that we're seeing is that we are seeing emerging regulations from the White House, from the EU, from all geographies that are taking a look at how do we enhance security. Security is becoming, and trustworthiness is more important than ever. And what we're noticing is that there's a shift of liability for insecure software and products and services that are moving towards all of us in this ecosystem. So it's incumbent upon us to take action to enhance security as an ecosystem and really make sure we're taking a look at the approaches of, hey, if we have robust appraisal frameworks where we can really understand and assess, we can do better together as a community. So one of the challenges with the current assessment model that many of us are involved in, as I can speak from a Google or Microsoft perspective, both of us require these types of assessments when we're looking at, say, an SSD or other types of devices. And right now, it's really opaque and challenging, and we can imagine that it's even more opaque and challenging for some beyond us. And so what happens today is you have what we would call a producer that's producing the device, or you could call it the supplier. So the device vendor or the producer has artifacts, like they have code, they have other pieces of information, and those come about in a software firmware binary, or you also have a checklist of the different components, other pieces that go on. And you have this consumer, say a hyperscaler customer or other customer, and so we request and we say, hey, we really want to see this, and then we kind of sometimes end up marrying to an auditor that reviews and the source code, scans for vulnerabilities, provides a report, but it's really messy of how does all of this get done and done in a robust way, and make sure that all of us are having that transparency that security is really based on. So when we look forward, we wanted to talk to then the challenges with today's model, so I'll hand it over to Bryan.
All right, thanks a lot, Amber. So yeah, with that previous model that Amber talked about, there were a lot of challenges in it. Some of them are those audits. You know, the way that flow of data went was the manufacturer would provide the device, and then the consumer, whether it was a hyperscaler or enterprise, would have to go and get it get a security evaluation done on it. And making that systematic or continuous was a real challenge. So they tend to be like these point in times. At the point of consumption, you would have those devices reviewed, but then as they need to be serviced or updated, it's like, what do you do with incoming updates that are different to what you procured maybe 6 months ago? And trying to get those reviews done again. And without those reviews happening during the life cycle of the product, another challenge would be that the security vulnerabilities would be found very late in the life cycle, late in the deployment life cycle, when the consumer has purchased the devices, they're running them through their tests, they may get a vulnerability disclosure, and then that whole process going back and forth between the auditor, the consumer, and the manufacturer, it kind of made the consumer a man in the middle between this whole flow. So that was often a challenge. And then another issue was when the consumer gets the security review on the device done, it becomes exclusive to that one consumer. So the manufacturer can't use that audit again with other customers. And that created a lot of duplicate audits where each consumer would go get their own audit done, and then the results of those audits or the findings, when they, if they were clear, if there was findings, they would be exclusive to that consumer. So that whole flow caused a lot of challenges. So when we looked at, oh, sorry, it went too fast. When we look at what were the key components for hardware security and having like integrity in it, there was a course during like the development of the product and then any future updates to the product. There's a security assessment that's going to provide security assurance. There's another component, a reference integrity manifest, and this really gets to the heart of how do you tell a component is secure. We have in it a root of trust that gives out measurements, but what do those measurements actually mean? The measurements are a concise representation of the security posture for the device, but an end consumer can't really internalize those or understand what a good measurement is from a bad measurement without some reference. So then they get a reference from the manufacturer, and then that reference would come in the form of a reference integrity manifest, and then it would point to additional measurements inside in the manifest. And they you know, if the device is running the firmware it's supposed to run, those measurements would appear in that manifest. But again, the measurements are just saying it's a concise representation of maybe firmware version A, but the end user doesn't know whether A is secure or whether they should be running B. And that's where the security assessment comes in to play. So the model that we envisage with S.A.F.E is not one where the consumer gets the security audit done on the device, but it's one where the producer works with OCP S.A.F.E approved auditors or security reviewers to get that security appraisal done. And then when that security appraisal is done, they agree with that producer that that's the final appraisal that they want done. And it's clear of vulnerabilities and it meets all the requirements in the checklist. And then they send that back into open compute, and then all consumers get to utilize or get to view that same security audit. So the manufacturer or the producer only does the audit once instead of doing it with each of the different consumers and not getting anything back that it credits them for having a secure device. So in this model, we see it as a systematic appraisal framework. It's not a kind of one and done at the start of a product's life cycle when it's manufactured. Of course, security evaluations should happen during manufacturing, and security is a continuous process. So when there are updates or changes that are going to change the measurements from the device, that would be accompanied with a new reference integrity manifest and a new security appraisal. Of course, it's a delta from the previous one, but it goes back through the appraisal process. And some of the early questions that we got in the security work group at OCP was, is this different to FIPS or common criteria? And it is, because it doesn't fit. It doesn't try to put devices into a specific profile, as not everything's going to fit inside in a square box. So it's pretty flexible. There's some checklists out there on what auditors look for in devices, what they're appraised for. Security requirements are out there. These are all in checklists. We'll get to a little bit later. And that's really what the assessment is focused on, is it's OCP safe security assurance. And the goal is to remove all of that redundancy, that long lead time for manufacturers to realize TAM, as each customer has this like 3-month onboarding process where there's this back and forth with security reviews that they can't just accept the goods straight from the manufacturer. So a little bit about the details of OCP S.A.F.E. It's under the leadership of the OCP Security Project. There are security review providers and checklists that get filled out by participants. The security review providers are those industry-recognized security expertise. There's firms there, IO Active, NCC Group. There's some of the early security review providers that have joined the group and really helped a lot in putting this framework together. There's a device checklist, as I mentioned, that suppliers fill out about the device and the security capabilities and features it has. And then when the assessment is completed, there's a badge that goes on the device and as it's listed in the OCP marketplace. There's also a short form, we call it a short form audit receipt, which is really an attestation from a security reviewer to say they've reviewed the device and it does meet the defined checklist. What the manufacturer has described. It's been scanned for vulnerabilities and that, to the best of their knowledge, that none of those exist. So the industry participation that we have, so I mentioned our security review providers and 3 companies that have really been instrumental in putting this together, as well as Google and OCP have really helped us to put this together, have been Atreides partners, IO Active and NCC Group. They're the security review providers. There's a process for others to join and become a security review provider. The checklists for those and the requirements for that are up on OCP. There are device vendors. So we have some device early participants to go through the process. And, we have AMD, who's, been a leader on Calyptra and an OCP on other transparency efforts. They really take, security very seriously, embrace this program, and they brought one of their GPU products through this process. And then we have Intel that's been demonstrating the end-to-end attestation flow out in their booth in the expo hall. And then SSD manufacturer, SK Hynix, they also brought their products through the OCP S.A.F.E audit. And they've all got reviews published out in the OCP GitHub around the claims of security on those products. And then the consumers of it, of course, are Google and Microsoft. So then to get involved and kind of the call to action is this is governed, under OCP and the OCP security project. The participants in that project really have input into the program, the security requirements. Out there, you'll find a project page that's been set up specifically for this OCP S.A.F.E. That's the first little hyperlink in the top of the page. So it's ocp.org or opencompute.org projects / OCP S.A.F.E program, and you'll find all of the information out there about the program, the requirements, the checklists. Then there's also a GitHub that has additional collateral inside in it, including the audits that have been performed so far, the security assessments with those short form audit receipts. And then, of course, products are getting listed in the marketplace, those products that have been marked as OCP S.A.F.E. So, any questions? Of course, on OCP S.A.F.E, you can reach out to Steve, Amber, or myself, or anybody in the OCP security project. So with that, is there any questions?
Yeah, the checklists that are developed, where are those coming from, and where? I think you mentioned that there are already audits that are done in place, and it's not like a profile, so it's. Could be slightly different depending on the type of device. But for like a singular device like SSDs or GPUs, are they following a specific set of criteria for that? Or does the vendor get to say, these are the things that I want to have checked out, and then I'll get a stamp of approval that say these things are valid? how do we know that it's a comprehensive review?
Absolutely, and that's defined. That's what the checklist is targeted towards. So it doesn't create specific profiles. There are things that are looked at in the review, like specific things around. Variables are validated correctly, and there's no memory safety issues inside in the device. So that's like kind of in a common bucket. But then there may be more device specifics that the vendor actually the manufacturer gets to detail what in the device, like what capabilities the device has that need to be validated. So there's a bunch of claims around capabilities for a device, and then there's an assessment that those claims are actually true.
And I think just to add, I think there's that common, right, that's there that we'll all have, but I don't think that it replaces where you may have a few things that are specific to what your requirements are, that you could, of course, always work with your vendors to make sure that they're getting those assessed so that you could get that as an augmentation. So we're not trying to make the program cover every single corner case, but the 90, 95%, if that's fair.
So after the assessment is done, are we going to have access to the results in terms of like what are the findings, mitigations, what happened during the assessment?
Absolutely, that's a really great question. So the assessment is, if I just maybe go back a couple of slides here, because I'll talk about how this doesn't really detail how the assessments work, but it kind of does if you can follow me. So the producer, I'm going to talk about the traditional model and then how this is different in the new model. So if we look at the prior to OCP S.A.F.E, the model that existed, if we call it the current assessment model, is the producer would produce some goods. Let's say it's I think everybody seems to be gravitating towards SSD, so we'll use that as a hypothetical example. So let's say it's an SSD. The SSD manufacturer sends that device over to a consumer, Microsoft or Google. We would enlist, we get some firmware binaries with the device. We would have a discussion with the manufacturer around its capabilities and the features of it, and essentially collecting the information needed to perform an audit. And then we would get that source code from that manufacturer, and we'd as big hyperscalers we would have in-house, like large security teams. I think Project Zero is like probably a really good renowned one, and Microsoft has a security response team that do a lot of this for our own product internally. But we're buying so much equipment that we'd often enlist like an IO Active or an NCC group or a Threadis to do a security review. So we get that source code, and then we go to the security reviewer, and we have them review it to the criteria that we want it reviewed to, and then they have findings. I've never seen a clean report come first time. There's always findings. Then we take those findings and go back to the manufacturer and say, hey, all these things were found in your device in the firmware. Go fix them. And then there'd be this back and forth, and then we get it reassessed eventually. And we're like, it is so much back and forth in this. The manufacturer wants to hit TAM. They want, start buying the device right now, and we're doing this, middleman of ferrying security audits back, and then taking the next release and sending them back over. And there's just a lot of back and forth in that process. And then, of course, manufacturer gets this. What every hyperscaler they go to is this security audit has to happen. So they get this 3-month back and forth, and it's unnecessarily long. So the way we change that model is the relationship between the auditor and the manufacturer is that one-to-one relationship. There's no hyperscaler in the middle. There's no OCP in the middle. OCP is governing it. We'll get to that in the next slide. But the audit, the producer, the manufacturer may send the firmware off to get audited, and the auditor will come back with findings and give that to the manufacturer. That will stay between the manufacturer and the auditor, those findings. The report doesn't get published until the findings are, the manufacturer decides when they're going to apply to be OCP safe. right? So that relationship of going back and forth until the device is secure and they have an audit, maybe it's a 100% clean audit that comes out, or maybe they're happy with some low vulnerabilities and saying, yeah, let's just leave those there, they're benign, go with it. And actually, I think if you look out there, I don't know if all the audits come back clean through the, it was back and forth for the early programs. That's exactly how it worked. Devices, there was, all the devices audited. There were things found and they were fixed, and it went back and forth. But that happened between the auditors and the device, the device manufacturers. So it's not like, these audits get published as soon as the auditor reviews it. No, that happens between the manufacturer and the auditor. And I think this is kind of the flow where the device vendor goes to the auditor. It doesn't really show the back and forth nature here on the I guess left of that diagram. Let me see. Sorry, right. It's left for me. If that diagram is the device vendor working with the SRP, they kind of go back and forth and have a dialogue, and there may be several iterations of the review as fixes are made. And then the final artifacts, that audit report, is sent back to OCP, and that's what gets the marketplace approval.
Thank you. My only concern is that probably the auditors will not push as hard as the hyperscalers or the final customers to have fixes, right? Like sometimes the vendors say, well, we're gonna fix this, or you can survive with this or whatever. And then hyperscalers will actually push for that in the old model, right? So I'm not seeing how, in this case, the auditors will actually have that power and decision to go and make the vendor fix things.
Yeah, that's why it's really important that the auditors, and when you see the auditor checklist and the scrutiny to become an auditor, is they are a trusted entity in this flow for the removal of to ensure devices are secure and safe. And they don't publish. Their integrity is on the line too, and all of this is public. So they're not going to publish something saying there's no vulnerability in it when they intentionally knew. And so the part of making this kind of publicly visible is all part of that, is keeping those checks and balances. And then because we have this framework, it doesn't mean that there won't be spot checks or secondary audits that happen along the line. And then if that's caught, then that SRP is kind of done reputationally, right? I think you got to turn that mic on. Yeah, you just got to swap them over, I think.
Okay, how about now?
Yep.
So the SK Hynix report that got published, there were 2 findings in there, but in order for them to comply with TCG Opal, they have to allow a zero-length password. So it's in there, it's listed, they comply with Opal, but other people may want to know that you could set a zero-length password. So it's a finding, but many customers aren't going to care about that. And it's to comply with another standard. So
Yeah, it's benign, but it's a finding.
Hi, sort of 2 intertwined things. One, is this all reputation-based, or are there any liabilities involved?
That's a really great question. So, one of the things that we see is there are measures for liability, coming. I think Amber talked about it, where their government is posturing on accountability for negligence or shipping unsecure products and not doing due diligence. I think both in Europe and the United States, that's moving ahead. So I think this is a demonstration of due diligence on that part to mitigate some of this some of these impending changes.
That's a good expression of it.
Yeah.
One place where that sort of is an OCP and general market need right now in storage is an evaluation of sanitize capability and whether or not a particular device in firmware is doing what it says it's doing, because it's really not checkable outside of the interface. That would be a great extension, but will probably require a different set of auditors than what you have now in a different set. I would imagine Eric's been talking about that in meetings.
Yeah, a lot. And on that, we have a solution coming for that, and there's a talk about it tomorrow in the security track. So I don't want to steal their thunder, but yes, absolutely, device drive sanitization, all of those flows, and it's for sustainability too, right? Right now, I think all major CSPs are crushing drives because of this exact problem. Yeah.
Great. When is that?
Come tomorrow to the security track. The time for the key management, you guys know? I don't know offhand, but you'll see it on there. There is a kickoff on that. I could give you a time now, but it'd probably be wrong.
Thank you.
All right, thank you. Any further questions? I know. All right, thanks a lot. Yep.
Cheers, man. Thank you.